All right, you guys, our very first word problem here. So I know we've done a lot of work in class already with what this whole story, it's a terrible line, what this whole story is about. So I'm just going to quickly go through the answer here. Here's my pool. And then I have a patio of a constant width that surrounds the pool. And I'm going to highlight that because those are the two words I picked out. Surround and constant, right? Constant width. And that means that I'm going to make the patio green too. I have this patio that's all the same width. It's not skinnier anywhere. It's not fatter anywhere. I mean, I know mine kind of looks like that, but it's not really. Around the whole pool, okay? All right, so there's some things I know, right? I've got numbers, words, and formulas. So my numbers are the area of just the pool is 150 feet squared, okay? And that's the area of the pool. And the dimensions of the pool with the patio, so all this green is one side is 20 feet, and one slash like that means feet. And one side is 15 feet. Now, a lot of you had the idea that we could find the area of the whole thing and then find the area of the pool and subtract. And you can do that, but that doesn't actually give us the answer we're looking for, right? That gives us the area of all the green, just the green part. But what we actually want is, let's see if we can pick a different color here. What we actually want is the dimension. So we want, oh, that's a little bit too fat. We want the length of this yellow side and the length of here. So we want to know the dimensions of just the pool, right? And a lot of people were able to figure this out kind of by using their common sense and guessing and checking, and that's always awesome to do if you get stuck. I'm going to show you how to actually make the equation that you can solve. So we're dealing with area, right? So we have area equals length times width because it's a rectangle. And we know the area of the pool. So I know that the area of the pool is equal to 150, and the length of the pool, that's what I'm looking for. I'm looking for the length, and I'm looking for times the width, right? Well, that's where this constant part comes into, because I know the length of the pool is going to be smaller than 20, right? So I'm going to take 20, and I'm going to subtract something from it. And what am I going to subtract? I'm going to subtract this amount here, and I'm going to subtract this amount here, and they're the same amount. So I'm subtracting 2 of those x's. And then on the other side, it's 15 minus 2 more of those x's, right? It's smaller than 15 by x here and x here. And the reason this works is because it's a constant width, right? So it's a quadratic relationship, and I'm going to use the quadratic formula over on the left-hand side. I'm going to write it out. It's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. First things first, I have to set this equal to 0. Well, first things first, I'm going to multiply 20 minus 2x times 15 minus 2x, right? So 20 minus 2x times 15 minus 2x, and I'm going to set up my area model here to help me multiply. Okay, so 15 times 20 is 300 positive. Negative 2x and positive 15 is negative 30x. Negative 2x times positive 20 is negative 40x. And negative 2 times x times negative 2x is positive 4x squared. So now I know I haven't changed anything. I've just made it look differently, that I have 150 is equal to 4x squared. That's this part here, right? And then I'm going to combine the middle term. So instead of just negative 40x and negative 30x, I have negative 70x. And then plus 300. Now I'm going to subtract 150 from each side. So now I have 0. If I subtract 150 there, I get 0 equals 4x squared. I can only subtract 100. Oops, what did I do there? I can only subtract 150 from the 300 because those are the only like terms. So instead of plus 300, I have plus 150. Now, my A is positive 4, my B is negative 70, and my C is positive 150. Okay? So now I can enter that into my quadratic formula. Negative B is going to be positive 70 because negative, negative, plus or minus the square root of 70 squared, which is 7 squared is 49, and add 2 zeros, minus 4 times A times C, so 600 is 4 times C, or is A times C, and then times 4, so 600 times 4, 2400. I'm doing this in my head, so please let me know if I've made a mistake. All over 2 times 4 is 8. Okay, so now 4900 minus 2400 is 2500, I think, right? Maybe I should use a calculator here just to double check. Okay, so I have 4900 minus 2400. Cool. And I'm going to take the square root of that. Nice even number. So I have two answers. I have 70 plus or minus 50 all over 8. So one answer is 70 plus 50, which is 120, divided by 8. And one answer is 70 minus 50, which is 20, divided by 8. And only one of those answers is going to be correct. 120 divided by 8 is 15. And I know that can't be right because my x is this little part right here. And it's going to be less than 15, right? So what is just 20 divided by 8? 2.5. So I'm guessing that this x here is 2.5. So that's the correct way to go. 2.5. Both answers complete the equation, but in the real world situation, x is going to be 2.5. But don't forget that hasn't answered the question. That's just the outside part. So if the whole thing is 20, the green part is length is 20, and this x here, I'm looking at the green, I'm circling the x, that's 2.5, and this is 2.5, then on the inside, it's 15. And over here, if this is 2.5 and this is 2.5 over here, I subtract out from 15, this side 10. So the dimensions of my pool are going to be 10 by 15. Like I said, a lot of people just figured this out using common sense or guess and check. So you can always do that. But let me know if you have any more questions.